Let's discuss the concept of graceful shutdowns. So when an instance is shut down in Cloud Run, a SIGTERM signal is sent to the container instance before that container instance actually terminates. So this can be due to an event like scale down or a deleted revision. So by handling that signal, that gives our applications a bit of time to clean up. Maybe it's sending logs out, maybe it's deregistering from a load balancer. If for whatever reason that SIGTERM signal can't complete within 10 seconds, the container does not exit gracefully. It will have a SIGKILL signal sent, and the application will be closed. So if you don't write a signal handler for SIGTERM, your process is going to be terminated instantly. So graceful shutdowns are great for doing things like flushing monitoring data. In abrupt shutdown, you don't get that last bit of monitoring data, and we want that. So we can develop a signal handler, call a function, flush out all the trace bands, and then send them off to our monitoring system. We can do log termination of our container, so if we log termination events, we can refer to those logs and see when containers started, when they exited, why they exited, and we get the full lifecycle, right? But if we don't gracefully shut down, we're going to be missing a lot of these logs. And close file descriptors or database connections. If we abruptly quit database connections, then they may leave connections open in a confused state. And as a result, they're not going to be able to accept a lot of more open connections because they already have stale connections open. So you want to gracefully shut down any interconnecting signals. We want to trap signals, and we want to trap them the right way. Most modern programming languages have libraries that you can trap termination signals like SIGTERM. And if it doesn't receive the termination signal in Cloud Run, the main reason for this is because it's not running as an init process in PID 1. So the parent process doesn't know how to forward that signal appropriately. Right, if it's PID 7, 8, 10, how does the parent process know which one to forward the signal to? So it has to be 1. And then the parent process can look and say, yes, it's in PID 1. Let's pass that signal on. The main reason your init process is not running as PID 1 is because the entry point statement is not set directly to your application process in your Docker file. And some getNew and bin, sh and other shells like bash don't forward signals to child processes by default, so you have to write your entry point statements in a vector form. Your init process can be used to kick off background process in your containers, but you need to use a proper init process that can forward signals to child processes. So Tiny, dumb init, and supervisored are all capable of this. In order to implement a graceful shutdown in code, let's take a look at an example for a small Node.js server. So if we add this snippet of code into our Node.js, we're saying turn the process SIGTERM function on. When you receive the SIGTERM signal, we want you to gracefully exit from the application, spit out hello world, receive SIGTERM, now we're exiting gracefully in the console, log, and then process and exit. And that's it. We don't have to add any additional settings to enable our graceful shutdowns. Very easy. So just find your language of choice and then find the code that corresponds to implementing these graceful shutdowns and the SIGTERM functions. You can also use shutdown scripts, so you can create and run scripts that execute commands right before your machine is shut off or restarted. So if you rely on automated scripts, then shutdown scripts are a good choice for you and they're useful. You can implement them with Linux VMs using a root account or Windows VMs by using the system account. There are, however, some limitations with shutdown scripts. On demand, you have 90 seconds to run. Preemptible instances, you have 30 seconds to run. It's also done on a best effort basis, so it executes shutdown scripts on a best effort basis. In rare cases, there may be times where the compute engine can't guarantee a shutdown script is going to complete. And on Windows, the local group policy is used to launch the shutdown script, and that's the local group policy, so there's limitations with shutdown scripts. If you do use shutdown scripts, there's a few things you should discuss. So they're triggered by certain configuration and power interface events. Restarts, stops, all, right? A shutdown script runs if an instance gets shut down to an instances.delete or instances.stop API requests if the preemption process takes place when an instance shuts down. During a request of a guest operating system like a sudo shutdown or a sudo reboot, or when you shut down an instance manually, whether it's in the command line or in the cloud. So back to shutdown script running time. There's a limited running time to run these shutdown scripts. We know that with preemptible instances, you have 30 seconds. So for 30 seconds, you need to be able to do all the actions that your shutdown script wants you to do. Your normal instances, you get 90 seconds, right? So these shutdown periods will change depending on the type of instance. So something to be aware of when you're designing your shutdown scripts. So what about when you have a shutdown script that lives on your local computer? Well, first of all, we can use a script file, and we can pass in the script file locally as long as it is not exceeding the length limit of 256 kilobytes. We can pass that into the gcloud command line tool. We can provide shutdown script contents directly, so we can pass in the contents of the shutdown script directly. Or we can script on Windows instances. We can choose from any of the specialized keys that you can use, where each key should match the type of script that you want to run. The Cloud Storage Shutdown Script. So you can store and use shutdown scripts from cloud storage. There's instructions for the shutdown-script-URL, as well as the startup script URL. So for Windows instances, replace the Windows startup-script-URL with the Windows shutdown-script-URL. We just want to have Windows in front of it. How do we apply a shutdown script to running instances? You can supply the shutdown script contents directly using the shutdown-script key, or you can supply a cloud storage URL to a shutdown script file using the shutdown-script-URL key. Learn how to identify best practices for using Google Cloud. Google Cloud Best Practices. Your host for this session is Richard Spencer. So let's discuss some GCP best practices, starting with organizational setup. You want to ensure that you define your resource hierarchy in a way that works for you. So the top-level node of a hierarchy is an organization resource, and that organization resource represents your full organization. Next, you have folders, and these folders are used to isolate requirements for different departments and teams in the parent organization. So the structure of your organization and your projects are going to be a very important first step. A general recommendation is to have one project per application, per environment, so that keeps your creation a little bit higher. You're creating more projects, you're creating more applications, more environments, but it gives you a good idea on the hierarchy that you've set up. And then from there, you can fine-tune that original organizational setup. But it's important to get your hierarchy, understand the different nodes and the different structures on how you create your organizations. There's some best practices regarding identity and access management. You want to manage your identity, specifically your Google identities, because Google Cloud uses Google accounts for authentication and access management. So all your users, your developers, your administrators, they're all going to need Google accounts with their Master Node. You can also federate your identity provider with Google Cloud. So if you have Active Directory or some on-premise identity provider, you can synchronize that user directory into the cloud. You can migrate unmanaged accounts. So if members of your domain have used their corporate email address to create a personal Google account, then you can migrate these accounts. So they can also be managed by Cloud Identity. Once you have all the identities and users created, it's time to control access to resources. So you want to implement something like a role-based access control, right? Keeping in mind the principle of least privilege so that people only have the access to do what they need to do to perform their jobs. Groups and service accounts. Take advantage of groups and service accounts to delegate responsibility. So you should collect users with the same responsibilities into groups. It makes it much easier to apply permissions to one group as opposed to 50 individual users. Right. Once you add those users to the group once, then you can treat all those users as one entity. And you want to understand and implement an organizational policy. So the IAM policy will focus on who provides the ability to authorize users and groups, and you set policies and resources in the resource hierarchy. So one policy for legislative significant driver, compute, may be different than a policy for GKE. Right, and it's up to you to define these organization policies. Network and security best practices. Use a VPC to define your network. Once you use VPCs, you can integrate ACLs, you can integrate security groups. So you have that much added security when you integrate with a VPC. Take advantage of the firewalls, right? So manage your traffic with firewall rules. You don't want to open every port to every person, right? Maybe you want to open up port 80. You want to open up port 443, port 22, or if it's internal, Maybe you only want to open up port 3389 for database traffic. Make sure your external access is limited. So if you do choose to have an external public-facing server in your VPC, you have to make sure that it does have things like a cloud net so that it can get out. But the point here is to limit access to the internet to only resources that need it. Alright, a database server doesn't need a ton of access to the internet. It needs to be able to go out and get updates, possibly. So that's where a Fori Silvermine 3 would come in handy. A front-facing web server would want a public IP address, but don't put public IP addresses on parts of your system that should not be accessed from external sources. Centralize your network control. Use a shared VPC to connect to a common VPC. Therefore, you have resources in two different VPCs that can communicate with each other in a secure and efficient manner. Connect to your enterprise network. You may want to connect to existing on-premise infrastructure. So if you need low latency, highly available enterprise-grade connections, you can take advantage of Cloud Interconnect. And that allows you to send data from on-premise to SIGKILL without traversing the internet connections. And finally, secure your applications and data. Google Cloud does provide some security from the hardware side. You have to secure your applications and the data that you're being trusted with. Logging, monitoring, and operations. Always perform logging and monitoring and centralize that logging and monitoring. It can be very difficult to get logs and organize all your logs from all your different applications and your workflows and different platforms and organizations. And if you can't get the proper logging and monitoring, it's hard to evaluate the health of your application. So logs are the main source of diagnostic information. So you want to make sure that you get these and you centralize it. And it's very easy to pull information from these logs. You want an audit trail, so every API call in Google Cloud can be audited with an audit trail using Cloud Audit Logs. And that tells you who did what, where they did it, right? Who shut down an instance, who reserved the public IP. I mean, everything is shown in an audit trail. User logs, export your logs. Take those logs and put them in a data analytics program, cloud storage, BigQuery, whatever the case may be. But those logs don't have to just sit in one system. And site reliability. So embrace DevOps, explore site reliability, take advantage of high availability infrastructure, take advantage of automation through CI/CD code pipelines. All right, the opportunities here are way endless. Cloud architecture. So best practices for your cloud architecture. Plan your migration, every step of it, right? There's a few different migration strategies. There's lift and shift. There's transform and move. Some people choose to migrate on a per-app basis, so make sure you plan that migration. Use managed services. One of the main advantages of the cloud is that you can use managed services. And as a developer, you don't have to worry about the underlying architecture and underlying servers. You can stick to what you do best. Plan for high availability and plan for disaster recovery. So, high availability, use multiple zones. For disaster recovery, use multiple regions and any combination thereof, right? So cloud is perfectly streamlined for disaster recovery solution. Of course, everyone's favorite billing and management. So you want to know how your resources are charged. Be familiar with your cloud billing account. Be familiar with the consumption of your resources and the prices of these resources. Make sure you have your proper permissions set so people can have the proper permissions to go in and look at your bills. Maybe it's account payable department, whatever the case may be, but specific permissions will have to be set to view this data. Make sure there's analysis is done on it. You want to just do more than take the bill and pay it. See what projects your biggest bills are coming from. Who's running these big line items, right? Analysis will go a long way. And your requirements. So plan for your capacity requirements. Google Cloud projects have quota that will limit the consumption of a particular resource or API. So if you're expecting a large amount of traffic, you need to plan those capacity requirements to prevent any unexpected limiting of your resource consumption. More billing and management. You want to implement cost controls, so as cloud services go up, their costs will go up, right? The more you start to store, obviously, the more cost to store a gigabyte is not going to be as expensive as the cost to store a terabyte or a petabyte. So make sure you have some cost controls. All right. You get alerts when your budget reaches 50% and so on. Take advantage of support. You may have to purchase a support package, but you can raise support tickets. It's a good practice to establish support or triage desk